Thank you. Okay. This is actually a sort of a sequel to that talk in Japan.
Oh, I love that.
But I don't know how many of you were there, actually. But don't worry, it's not. You don't need to have seen the first talk. So we're going to talk about WebSockets. Let me quickly tell you a little bit about myself. Well, that's my name. I'm from. Ooh, this is very odd. This is supposed to show a map of Europe. I hope the other pictures work. Well, so I'm from the dark green spot in the center of that, which is Belgium. Best known for Belgian beer and chocolate and other tasty, yummy things. And odd-looking buildings. This is an iron crystal magnified 65 billion times. And apparently it has the highest toilet in Belgium. I live in a town very close to Antwerp. We have a beautiful abbey and a couple of castles, all very, very nice. And I started a company about 22 years ago called Cube Solutions. We build a lot of software, not a lot of Cake PHP, mostly Symfony stuff, some Python, some hardware integrations. And I've been doing all sorts of stuff with open source since around 1997. For those of you who don't know this project called PHP Compatibility, check it out. It's something you can use to see if your code is compatible with newer versions of PHP. So it will analyze your code. Or it will do the opposite. Let's imagine you're coding on PHP 8.2, but your production environment is still running 7. something. Then you can tell it to see, you can tell it to check whether your code is actually going to work on your production environment. And I've been doing talks like these for a while. Let's see who you are. Who here is a developer? Yeah, pretty much everyone, okay. Anyone doing system engineering as well? Okay. Who's ever worked with WebSockets? Not so many people. Okay, good. So, there's the old way of doing things, and by old I mean pre-2010, and there's a new way. The old way we used to show content, load a page, and then somebody would click, and then we would load another page. The new way, of course, is we want to show content and push real-time updates. The old way, the way it used to work, is the client would say, oh, get some page, and the server would return it, and then the user would click, and it would happen again and again and again. Then first attempt at real-time updates was Ajax polling. So you would say, get updates, and the server would reply, nope, got no updates. And again, nope, got no updates, until at some point there was some new information, and then the server would say, yep, I got an update, and here's the data. And then again, it would poll, nope, got no updates. Not very friendly in terms of server load. You're constantly polling, so this is not ideal. There's another way of doing it, which is called long polling, which is client says, get updates, and then it just sits there. The server doesn't reply until it finally gets new data, and then it replies with that update. But now you're holding that connection open on an HTTP server, which could be maybe Apache, which is maybe not ideal. So yeah, WebSockets work slightly differently. You initiate and upgrade a connection. I'll get back to that in a minute. And once that connection is open, once the WebSocket is active, then the server will send new data and send new data. But the client can also say, oh, I have a request, or I have something that I want to send to the server, and in the meantime, the server can communicate back. Everything can happen simultaneously, basically. You can have you can send multiple things at the same time from the client, and the server can send multiple things at the same time to you. So how do we actually make that connection? So there's a couple of different ways of doing it, but most people will use a standard web server, like usually Nginx. You can do it on Apache as well, but I don't recommend it because Apache is a bit more limited in terms of the number of connections it supports easily. So this is a request. Client sends a standard HTTP 1.1 request and says, for example, get chat client. Specifies the hosts, and then specifies a header upgrade WebSocket, connection upgrade. This is a bit specific to WebSockets. What will happen is the web server, if it supports WebSockets, it will recognize this and say, oh, I'm going to have to upgrade the connection. And from this point onwards, I'm going to let the WebSocket protocol, whatever it wants to do, deal with it. I'm not going to be bothered with it anymore. I'm not going to try to talk HTTP anymore. You can see there's a sec WebSocket key. That key is sent by the client, and the server will return a hashed version of it, which is sort of a way of saying, oh, I recognize you, and I authenticate that you are indeed speaking the same language. And you can also see there's a protocol, and there's a version. Now, the version is 13 and has been 13 for a very long time. The protocol, the client can theoretically specify multiple protocols that it supports, and then the server is going to pick one, or say, I don't support any of them, and then the WebSocket connection will not work. So the server will reply HTTP 1.1, and then it will not reply 200 OK. It will actually reply 101 switching protocols. Again, it will say upgrade connection. It will reply with that hash key, and it will mention which protocol it wants to talk. As soon as we have this situation, now information can flow in both directions using the protocol that they agreed on. In this case, I chose chat. Yeah. So those protocols, as I mentioned before, the client and the server has to support the same protocol, otherwise they cannot communicate with each other. There are several popular ones. The most popular one is probably WAMP. What's in there is PubSub and RPC, for example. We'll get back to that. There's Stomp, which is sort of a messaging protocol that's being used a lot. But you can write whatever protocol you would like. So you can say, okay, I'm going to write something that exchanges messages using XML or using JSON, and I'm going to split my messages every X number of bytes, and I'm going to have some kind of keep alive system in there. You can do whatever you want, theoretically. Most people choose to stick to WAMP because it's a common standard and it's been implemented by a lot of libraries and it's very versatile. What's important to know with WebSockets, because you're communicating in both directions at the same time possibly, is you need to have asynchronous communication. So both the client and server have to support this, otherwise, well, the server could be sending you a lot of data and you're still processing on your client, you're still processing something, and the data is coming in, but you're not actually receiving it anymore. You're not doing anything with it. Luckily, PHP can do async. Actually, it can do it since PHP 4.1, although with PC and TL fork, that didn't really work very efficiently. But since 5.3, async has been around, so that works pretty well. And if we're talking about async stuff, then it means we have events. We need to handle events. So there's a couple of events, open, close, when the WebSocket connection starts and ends. There's a message event, which is when a message is received by the client. There's an error event. And then there's, of course, two methods, send and close. So what would you use WebSockets for? Well, synchronization of all sorts of data between, well, you could say between the browser and the server, but as we'll see later, it's not just a browser connecting to the server. It could also be two servers exchanging information over a WebSocket, or a mobile app connecting to, theoretically, another mobile app could even work on the same network. So anything goes there. A lot of HTML5 games, multiplayer games, use WebSockets to communicate. Live feeds. Live feeds. So, for example, if you're watching a live stream of something and you decide to click pause, that might actually trigger over WebSocket, might actually tell the server, hey, this person is paused, stop sending him new data. Or they use it a lot also for tracking, like when did he turn on captions? What language were the captions in? Did he fast forward at some point? All of that is being tracked. So they use it a lot for tracking stuff. Also, if you're on a website and there's live tracking of your cursor, things like that, a lot of that stuff is WebSockets as well. Then auctions is a good example. You don't want to be constantly polling, am I still the highest bidder? Am I still the highest bidder? No, what will happen is everybody on that auction site will connect to the WebSocket server. And as soon as a new bid is received, the WebSocket server is just going to send it out to all of them simultaneously over the active connection. Real-time updates, financial applications, and of course, the most common one, messaging or chat. Why do you do it? Well, you've got full duplex messaging. You've got stuff going in both directions, asynchronous. You don't have HTTP overhead because you don't constantly have to reconnect and have to send a GET or a POST request. The connection is open, the connection is live, so you've got low latency, and there's not a lot of overhead on bandwidth in terms of bandwidth either. And you can send multiple messages at the same time or receive multiple pieces of data at the same time, so stuff can be fragmented even, and that's not an issue. There's no caching, so that's a disadvantage because it's not really a GET request anymore, because as soon as that switching protocols things happen, there's no HTTP anymore. The data is still transferred over the HTTP protocol, but whatever is in there, it cannot be cached. Of course, if you want to implement WebSockets, you'll have to change your application a little bit, or a lot in some cases. There's by default no message acknowledgement built into the standard WebSocket protocol, but of course a lot of those protocols like PubSub and RPC definitely have message acknowledgement. And there's no ping pong or keep alive. There is one defined in the RFC, but apparently nobody's implementing it, so a lot of the protocols have actually built it themselves. So if you want to use WebSockets, there's basically two ways of doing it. You can either use a WebSocket server that runs by itself, listens on a certain port, and then you connect to it, and then you can do whatever that WebSocket server is designed for, whichever protocols it speaks. Or you can actually build one yourself using some library, for example in PHP, as we'll see, and then you define what is available. Now, both have advantages. If you use a separate WebSocket server, for example, Crossbar is the most common one, you can use things like PubSub because it's already available in that WebSocket server. You can have a client connecting to the WebSocket server and registering an RPC call, which we'll see later. Then it's actually the code for a certain RPC call is not going to run on the WebSocket server. It's going to be running on a certain client. There is a bit of extra work in terms of infrastructure setup because you have to set up a WebSocket server. However, it's easier to separate a lot of concerns or domains, and it scales a lot better. Whereas if you build it inside your code, well, you have full control. That's a plus. But it also means that it doesn't scale as easily. We'll see how that works in a couple of slides. So let's look at some client code. Normally, you would never write this kind of code, because if you're using things like Vue.js, well, they have WebSocket support built in, so you're never going to do new WebSocket and then the URL. So in this case, the WebSocket is opened with WS. There is WSS, which is secure WebSocket. And we're just going to connect to a certain URL, and we expect a WebSocket server to be running on that specific URL. He's going to try to do switch the protocols, upgrade the connection, and so on. Once we have a WebSocket object in JavaScript, we can define an onOpen method, on open event, an onMessage, and an onClose, and we can do things like send a message, and of course close the connection again. Very simplistic. This code really doesn't do a whole lot at all. If you want to send information, either you send it just as a string, you can send a piece of JSON by stringifying it, or you can send an object and give it a type as well. That's the very simplistic one. As I said, you would normally never use this directly in JavaScript because you'd use some kind of library that wraps around it and gives you all sorts of nice capabilities. Okay, let's look at how we would build a very simple WebSocket server in PHP. So in this case, we're not going to use Crossbar or some dedicated WebSocket server. We're going to use one that we can actually implement. We're going to use Ratchet, which has been around for ages, but works really well. So we define a class, my WebSocket server, which implements a certain interface. We define an open method, which is just going to immediately send a message out. And we have an onMessage, an onClose, and an onError, which we currently don't do anything with. How do we start this WebSocket server? We initialize an HTTP server, say, oh, we want you to use a WebSocket server, give it our class that we just defined, and say, you need to run on this specific port. And we just run it. And now we have a WebSocket server that's listening on port 1890. If you telnet to port 1890, it will immediately send you test message. We can extend that a little bit, and we can say, okay, our class that we had before, I'm going to store, I have a property clients here, and it's going to be an SPL object storage. And whenever somebody connects to our server, to our WebSocket server, I'm going to add that client that connects to my list of clients. And whenever that person disconnects, I'm going to remove it from the list. Okay, so now whenever someone connects, we add it to the list of clients. Great. When we receive a message, I'm going to loop through all my clients, and if the message I receive does not come from this specific client, then I'm going to send the message. So basically, 1, 2, 3 slides, and I built a chat client. Because anyone who connects, and I type something and send it, then everyone else who connected to it receives that message. So that's how easy it is to just build a chat client that runs on a certain port. Would I do it this way? No, because let's imagine it's in a browser. I can now start sending like JavaScript stuff and XSS exploits and all of that. I actually gave a little demo years ago in Australia, and the day before I gave a security workshop. This thing was running on the network, and they started like injecting all sorts of weird things during my demo. So that wasn't that much fun. Okay, so there's a couple of protocols that you can use. I mentioned WAMP before. It has 2 things in there called PubSub and RPC. PubSub, who's ever used PubSub systems? Yeah, okay. So publish, subscribe. Basically, a PubSub system has a central message broker, as they call it. You send a message on it, you publish a message on it, you give it a certain topic and a certain content, and then anyone who is subscribed to that topic receives that message. Examples of existing systems are, well-known one is Mosquito, MQTT. Redis is another example of a system that uses PubSub as well. How does it work? Well, I'll take Mosquito as an example here. We have our user here at the bottom, and they can connect to the Mosquito. And they say, I connect, and I subscribe to the topic stock price. Now, whenever a message is published on the topic stock price, that user will be sent that message. So if we have an external source here, and that external source connects to our Mosquito and publishes a stock price for Amazon of 940, whatever, just took a number, then Mosquito is, of course, internally going to push that to the topic stock price. And now any user that was subscribed to stock price receives that update. That's how PubSub works in every single system out there. So this is very useful to exchange information that you want everyone to get. Like the example I gave before about an auction system, where if the bidding price is changed, well, everybody who is currently watching that specific item on which the bidding is taking place will be subscribed to the topic of that item. Well, we only have to push a new bidding price once, and everybody will receive it. RPC is the other thing that WAMP has on board, and WebSocket servers such as Crossbar have. And RPC basically means you connect to the WebSocket server, and then you can make a call, which is run somewhere by one of the clients that offers that call. So a client will connect to the WebSocket server and say, hey, I have a call available for, to run a specific piece of code. You can run that specific piece of code through me. And then any other client that connects to the same WebSocket server can make that call, and it will be executed on the other client. So let's take an example. Let's imagine a client connects to the WebSocket server and says, inside the code says, okay, I have a function here, which is basically going to return the sum of two arguments. Then if that session variable here is the WebSocket connection, that client can say, I register this specific name of the RPC call, and I provide it with my function. And then it's just going to sit there and wait. And then someone else, some other client, can connect to the same WebSocket server and say, call that method with these parameters, which is going to actually call that over the WebSocket server. So you have two clients. One of them is calling through the WebSocket server, the other method running on the other client. And for those of you who know the promise system in JavaScript or any other language, this basically, the then here means that if the call is successful, it will execute that piece of code. If the call is not successful, it will execute that piece of code. So why would you use RPC calls? Well, anything that requires things like approval or a status change before you're allowed to continue makes sense that you use RPC calls, or anything that you want to offload to another system. That could be a financial transaction. Like, you don't want to deal with the financial transaction here. You're saying, okay, perform this financial transaction and let me know when it's finished. It can happen asynchronously. In the meantime, you can do other things. It could be things physical, as we'll see in a minute. Opening a door, turning on a light, turning off a light. You basically say, okay, turn on the light, and then you wait, and it replies back, the light is now on. Okay, now I can continue and I can open the door, or something like that. For those of you using home automation like Home Assistant, it uses WebSockets in the background. Streaming, again, same story. You press play or you change a channel, things need to happen in the background. That's what RPC is very useful for. So this is a bit far, like the next step already. If you really want to scale up, because if you have a lot of users, you could be faced with the challenge, do I use a single WebSocket process or do I use multiple? Now, if you're using a thing like Crossbar, then you can handle tens of thousands of WebSocket processes at the same time. So that's not really an issue. If you run it on PHP, well, you might be faced with some issues at times. Normally, I would always say use a single one. Simple apps like a chat, you don't need multiple WebSocket servers, obviously. If you have a more complicated app, but your clients are trusted, well, don't worry, run it on a single one. If you have a complex app, or you have a clear separation of, okay, I want certain clients that are facing the internet, they can connect to the WebSocket server, but I have internal processes as well, you might want to separate those on a different server. Or high traffic, of course, it's the same thing. What's important to note is, if you have multiple, you get a lot more complexity, of course, that makes sense. Oh, and there's a piece of text here missing. If you decide not to run Crossbar, but you decide to write your own WebSocket server in PHP, which is fine, then whenever you do like a WebSocket, like an RPC call, for example, if something makes a call to your code, then whenever you are running that code, you're not communicating at that time. Because even though PHP can do asynchronous stuff, when you're actually running a process that's going to do database queries and so on, well, everything is blocking at that point. So that's why using a separate WebSocket server might make more sense, because you will be able to scale better. Okay, I want to talk about a couple of less standard ways of using WebSockets. So normally, if you were to implement a chat, for example, as I discussed before, if you have a WebSocket server and you have two clients connecting to that WebSocket server, they can both subscribe to the topic chat, for example. And then they can publish messages to the topic chat, and the WebSocket server will, using PubSub, automatically push any message that was received to everyone who is subscribed to that topic. The problem is, of course, at some point somebody joins the chat and starts swearing and starts doing nasty things, saying all sorts of things that you don't want. Or start sending XSS and other nasty hack attempts into the chat channel. What's the solution to that? Well, PubSub doesn't provide a solution. You publish and you subscribe. There's no way to, oh well, there's a way to filter it, but yeah, normally everything that is published is automatically sent through. What you can do, however, is turn it into an RPC call. So now you have what we call a mediator process, which connects to the WebSocket server and offers an RPC call called send message. And now, if they want to send a message, well, they have to use the RPC call. And then that mediator process can do all sorts of filtering, can do logging maybe as well at the same time, can do various things, and then it just sends back the message to each client. Another thing you could do is create an aggregator. I'm going to use an example of one of our clients. So this is a client, we build software for their locker system. So this is a locker at the locker unit at the Belgian Railways. So we have a little screen here, we have a payment terminal, we have a barcode/QR reader, there's a ticket printer in there, there's a whole bunch of hardware devices. And that entire system runs on a Linux computer that's in there, like a mini, it's like a 4-core, 4 gigabyte of memory, not super powerful, but powerful enough to control the whole thing. And then you can, on the screen, you can rent a locker or pick up a package because there's parcel delivery in there and so on. But as you saw, there's a bunch of devices in there. And for example, this payment terminal is needed in order to rent a locker because you have to pay for it. So if that payment terminal for some reason becomes unavailable, that button shouldn't be there. We use WebSockets to connect everything here. The hardware devices are monitored using processes. We have the UI that is using WebSockets and so on. And so whenever something happens in the system, other components can immediately be aware of that. How does that work? We have our WebSocket server in the middle. We have our UI, which is built in Vue.js, and it connects to the WebSocket server. And it subscribes to a bunch of things, and it can do RPC calls. And then every single hardware device that is detected starts up its own process. Most of those are Python. One of them is PHP for the printer. So, for example, we have our payment device. Our process runs Python. It connects to the WebSocket server, and it will basically say, OK, the payment device is available. It's online. It can be used. And the same thing here for the coin reader. Yes, some people still pay cash on those things. So it works over serial connection. So we detect automatically that it's there. We start a process, connects to the WebSocket server, and it says, yep, the coin reader is now available, and you can use it. Now, obviously, what we don't want is this process and that process constantly saying, I'm available, I'm available, I'm available. That's just too much, because here I only show 2 devices. In reality, we support about 30 of them. The UI would just be handling I'm available the whole time, which is pointless. It only needs to know when a device status has changed, because then it might have to hide a button or show a button or do something else. So for that reason, we have an extra process called a device status aggregator. And it will just listen to these processes announcing, hey, I'm available or I'm not available. Or it will just listen and check when was the last time I received I'm available, and if it's been more than X seconds ago, it will basically update the global status of all the devices. And then it will basically push that, so yeah, they will each publish their own status, and then the aggregator process will push over the WebSocket server. It will say, A was last updated then and is online, B was last updated then and is online, C is not online, so hide the button because it's not online anymore. This allows you to dynamically update everything that happens inside the system, even to the point where, let's imagine that we normally hand out an RFID card. If for some reason that device is missing, but we still have a ticket printer and a QR reader, we can actually print a QR instead, which can then be scanned. So it automatically falls back in that way. So we monitor all the devices automatically. This is a bigger list of devices, and you can automatically, based on this, update information. So that's what an aggregator would do, for example. Of course, the same thing goes for RPC stuff, because it's not just about, hey, what's the status, but also this device, for example, is a hopper. Basically, it can provide coins back. It can give money back. It works over serial, and you send certain commands, and then it can hop a certain amount of coins. So that's what it looks like. So here we can see we have a status. We can only detect whether it's full, middle level, or empty. There's nothing else. And we can say, okay, dispense a coin. And then we tell it how many coins it needs to dispense. So the RPC call that is in there will do that, but it will also reply, because maybe we asked it to dispense 10 coins, but there's only 5 left. Well, then maybe we can print a voucher or something else. Again, we need to handle that. So we have RPC dispense coin for that, which is, again, an RPC call across the whole thing. Now, it goes beyond this, because what if we have multiple physical devices? We have 2 terminals here, but they all together control all of those lockers. So we're clustering things now. So what we do is we have one WebSocket server. We have one UI on this side with all sorts of devices. And then we have another UI for the other terminal, but everything connects to the same WebSocket server. So they can know each other's status as well. Now, of course, at some point we have to open a locker. And we don't want both of these to be in control of opening lockers, because that could get a bit tricky. Plus, the device actually doesn't support multiple connections. So we have one of them, the master, that starts the locker controller and has an RPC call to open the locker door. And if for some reason this one fails, then that process will just start there. And the WebSocket server can also migrate to the other side. So anything basically goes, and we use the WebSocket server sort of as the central controller for exchanging information, but also doing things like opening doors and giving money back and so on. This is a very specific example, of course. I mean, this is hardware stuff, but it's not just hardware stuff. You can use WebSockets for infrastructure monitoring in a different way than most people do it. Most people use SNMP, and they poll every 5 minutes. They see if the disk is not too full, if the network is not too heavily loaded, and so on. You can easily implement stuff so that you get real-time updates about critical things. Any aggregation of events, whenever you have, for example, let's imagine that you need to upload, a user needs to upload multiple documents. Needs to upload an ID, and then needs to upload a document that needs to be signed, and so on. You could do that sequentially, of course, or you could say, well, I'm just going to upload all those documents simultaneously through RPC, and each call can be handled on a different environment, which makes it easier to scale. So that way you can reduce total processing time. There's a whole bunch of possible things you can do with WebSockets that go way beyond just chat or making simple calls for auctions and so on. Okay, I have some minor tips and tricks to finish with. If you want to use WebSockets and you want to use it behind Nginx, this one is a pretty critical one. Because by default, because it is a standard HTTP connection, it will use the timeout of a standard HTTP connection that's defined in Nginx, which usually is a minute or 2 minutes, but then your WebSocket connection will drop. So you need to actually tell Nginx, look, if it's a connection on that specific URL where your WebSocket URL is located, set the read timeout to an hour, for example. Same in HA proxy. If you want to learn more about WebSockets, this is an amazing resource. I will put these slides online, by the way, and I'll post the link in Slack as well. That's an amazing resource. It talks about how WebSockets work, but also all the various different ways that you can use them and ways that you can use them efficiently, and all the different libraries. Websocket.org is a good resource. The Chrome Developer Console has WebSocket support, Firefox as well. One thing to note is that if you want to see details on everything that's going across your WebSocket connection, you need to open the console first before the connection is established. Otherwise, it will not show you any of the details, any of the traffic going over the WebSocket. If you want to benchmark it, there's 2 tools for that. Yeah, I left this in there for backwards compatibility. If your clients are using very old browsers that don't fully support the WebSocket standard, but honestly, I wouldn't even go there anymore, because if they use a browser that's that old, well, they should upgrade. This is probably the best known WebSocket server, or definitely the most stable and most versatile one, crossbar.io. I checked yesterday evening and their website was down. Still down? Okay. It wouldn't even resolve DNS, so I don't know what's going on there. But so Crossbar is the server. It has WAMP support and a whole bunch of other stuff in there. The reason I went to the website was to check, because they were working on some automatic failover systems and automatic redundancy systems, and I wanted to check how far along that was, but I can't tell you.
I went in.
And then there's Autobahn, which is actually tied into Crossbar, and they have open source libraries for basically any language you can come up with the exception of PHP. But then there's a good PHP library called Throughway, which basically does exactly the same way. I would never recommend you to use in JavaScript, use WebSockets, barebone, just say new WebSocket. No, use a library, because it offers you a lot more flexibility, a lot more options out of the box. All right, any questions?
What would be the limiting factor on how many connections you maintain? Oh, yeah, of course. What would be the limiting factor on how many connections you could maintain with one WebSocket server?
It depends a bit on whether you do PubSub or RPC. With PubSub, the limiting factor, if you want to do it with your own code in PHP, the limiting factor would be how much your system can support on a single core. Because we have to forget, even though we are using pthreads, it's still one PHP process running on one core. If you're doing RPC calls, then your limit is basically how long does each call take, because they will all be handled sequentially. So if you're If each RPC call is, for example, doing 15 database queries, and they all take, well, a fraction of a second, but in total it takes a second, then you're limited to 1 RPC call per second. So the only way to then scale that is having multiple clients connecting to the WebSocket server and offering the same RPC call. So it depends a bit on PubSub or RPC. PubSub is easier, and if you use something like Crossbar, then, well, you're not limited to much basic. I mean, there's no real low limit. We're talking about 30,000, 40,000 connections easily. I've done 10,000 on PHP with PubSub too, and it can handle it easily. But as soon as you go to any RPC things that do database queries, then yeah, that's going to be your limit.
Thank you.
Anyone else?
Okay.
All right.
Thank you.
Okay. Thank you.